Hi everyone, in this video we'll go through few problems related to transformation formulae. Before we get into the problems, let's look at these two sets of formulae, which is very important. The first set is formulas related to product or multiplication of trigonometric angles, and we can express the product of trigonometric functions as sum or difference of trigonometric functions. First two formulas are based on sine, right? So if you have sine A into cos B or cos A into sine B, we'll have to use sine for both the terms, sine A plus B plus sine A minus B. Similarly, if you have cos A into sine B, then it will be minus here. And the third and fourth formula is cos based formulas. That is, you have cos for both the terms. The second set, if you have sum or difference of trigonometric functions, you can express them in the form of products of trigonometric functions. So in the problem, if there is sine C plus sine D, then we can write it as 2 sine C plus D by 2 into cos C minus D by 2. So here again, remember, if we have both the terms as sine, then we will have to use sine and cos and sine, right? And if you have both the terms as cos, then we'll have to use cos and sine. Basically, it has to be same terms. The first term and the second term should be the same thing in case of cos. The last formula in the first set, A minus B is the first term and A plus B is the second term. Similarly, in the second set, you have minus here. The best way to remember all these formulas is remember the first formula and the last formula, right? In both the sets. First formula and the last formula, if you can remember, it will be easier to remember the middle two formulas. Let's go through this particular problem where we have to prove that sine 2a plus sine 2b plus sine 2c is equal to 4 sine a into sine b into sine c. There are multiple such problems, right? The approach will be the same. Now, remember one thing, this is a second set of formulas, right? Where you have addition and you can express them into product. Why we will have to express them into product? Because the RHS is having products. It is sine A into sine B into sine C. So there is multiplication here. So we will use the transformation formula where we convert addition of trigonometric functions into multiplication of trigonometric functions. So these are the formulas. These are the formulas in the second set. This is the first formula, right? As I said, let's remember the first formula and the fourth formula. The middle two ones, it will be easier to remember if you know the first one and the fourth one. So sine C plus sine D, that is, both the terms are sine. So we'll have to use sine and cos. So sine 2a plus sine 2b, right? Let's use the formula for sine 2a plus sine 2b. So if you use this formula, it will be 2 into sine C plus D. Instead of C and D, we have 2a and 2b, right? We have 2a and 2b. So 2a plus 2b by 2, right? Similarly, cos C minus D by 2. Cos 2a minus 2b by 2. 2 and 2 will get cancelled. And then we will have 2 sine A plus B cos A minus B, and we have sine 2c here. What we can do is, we will have to remove this 2c, right? We'll have to make it as a single c, right? Because in the RHS, you have A, B, C. There is no 2a, 2b, 2c. So that's why we can substitute sine 2c. What is sine 2c formula? 2 sine c cos c. 2 into sine c cos c is sine 2c, right? And in the trigonometric identities, right, we had seen that if a plus b plus c is 180 degree, then sine of a plus b is sine c, right? We had seen this. There are multiple trigonometric identities. Sine a plus b is sine c, cos a plus b is minus cos c, right? And tan a plus b is minus tan c. So multiple such identities we had gone through in the last video. So in these kind of problems, we'll have to use all of these formulas, right? So sine a plus b can be written as sine c. Why we are writing this is because you have here sine c. Here we can represent sine c. That way we can take sine c as common factor, right? If you take sine c as common, you'll be left with cos a minus b and cos c. Cos a minus b and cos c. Now we know what cos c is. What is cos c? Here cos a plus b is minus cos c. So therefore, cos c is minus of cos a plus b. Minus of cos a plus b. So we will have to remember all of these trigonometric identities, right? So it's very easy to remember. If you have sine a plus b, then it will be equal to sine c, the third angle, right? This is the third angle, right? Similarly, if you have cos a plus b, then it will be again third angle, but with a negative sign. If you have tan A plus B, again it's a third angle but with negative sign. Now we have cos A minus B minus cos A plus B. This set of formulas is in the first set, right? Let's go to the first set. This is what we have in the expression, right? We have cos A minus B minus cos A plus B. So we can write this entire thing as, we can move this to this side. So it will become 2 sin A into sin B. So this entire thing can be written as 2 sin A into sin B. So now you see, you have 2 sin C, 2 sin A and sin B. So it's nothing but 4 into sin A into sin B into sin C, which is nothing but equal to right hand side. Hence we have proven this. Let's take another problem. It's similar to the earlier problem, just that instead of sin we have tan, right? Again, you have addition here and you have multiplication here. We went through 2 sets of formulas, right? 2 sets of transformation formulas. In that we have only sin and cos. We don't have tan based formulas. So what we can do whenever we find tan based expressions, right? We will take A plus B plus C is equal to 180 degree, right? Because it's told in the problem that A plus B plus C is 180 degree. Now we need 2A here. How do we get 2A, 2B, 2C? We multiply this entire thing into 2. So we'll get 2A plus 2B plus 2C is equal to 2 into 180, which is 360 degrees. We can write this as 2A plus 2B is, we can shift 2C this side. So you'll get 360 minus 2C, right? Now I'll apply tan on both sides. So what will happen? I'll get tan 2A plus 2B is equal to tan 360 minus 2C. If you remember, tan 180 minus C is equal to tan C is equal to minus tan C. Sin 180 minus C is sin C, and cos 180 minus C is minus cos C. For cos and tan there is negative sign. For sin it is positive. Now here instead of 180 minus C we have 360 minus 2C. It is double, right? So what we can do is, instead of C we'll put 2C. Instead of C we'll put 2C because this is double, right? You can write this as tan 2 into 180 minus C, right? You can write this entire expression as tan 2 into 180 minus C, right? So instead of minus tan C, I'll write it as minus tan 2C. There is a derivation here, right? I have derived this entire thing. How am I telling that tan 360 minus 2C is minus tan 2C, right? This is just for your understanding. What I have done is, I have written tan 360 minus 2C as tan 2 into 180 minus C, right? And now further, I can write tan as sin by cos, correct? Sin 2 into 180 minus C by cos 2 into 180 minus C. Now, this is nothing but, you can visualize this as sin 2A, right? You can visualize this entire thing as, say, A, right? You can visualize this as sin 2A and cos 2A. What is sin 2A? It is 2 sin A cos A. What is cos 2A? 2 cos square A minus 1, right? There are 3 formulas for cos 2A, if you remember, right? 2 cos square A minus 1, 1 minus 2 sin square A, cos square A minus sin square A. There are 3 formulas. We'll pick the one that is based on cos itself. 2 cos square A minus 1. Now we will substitute here. So instead of A, we have 180 minus C. So instead of A, we'll write 180 minus C. Now what we can do is, what is sin 180 minus C? Sin 180 minus C is sin C. Cos 180 minus C is minus cos C. We'll substitute this. And then here also, 180 minus C is minus cos C. So you have cos square here. So it will become minus cos square C, right? Now, what will happen here is, we'll get minus 2 sin C into cos C by 2 cos square C minus 1. What is 2 sin C into cos C? Sin 2C, right? Minus sin 2C. And what is 2 cos square C minus 1? It is cos 2A, that is cos 2C here, which is nothing but minus tan 2C. So we don't have to do all of these steps. This is just for your understanding as to how we said that tan 360 minus 2C is tan 2C. It's enough if you remember that tan 180 minus C is minus tan C. Therefore, tan 360 minus C is minus tan 2C. Because 360 minus C is nothing but 2 into 180 minus C. You can write as minus tan 2C. Now here, coming back to the problem, we can write tan 2A plus 2B as, we can use tan A plus B formula. What is tan A plus B? Tan A plus tan B by 1 minus tan A into tan B. So instead of A we have put 2A, instead of B we have put 2B, right? And instead of tan 360 minus 2C we have put minus tan 2C. Now what we'll do is, we'll shift this entire thing here and rearrange the terms, right? We'll bring all the addition terms here and all the multiplication terms here, because we need to get the RHS in the form of products. So this is the RHS, right? We have all multiplication here, and on the left hand side we have all additions. So just rearrange and we'll get the expression. Now let's go to another problem where we have to prove that sine 4a plus sine 4b plus sine 4c is equal to minus 4 sine 2a into sine 2b into sine 2c. Now same steps, right? We'll take these two terms. We'll apply the transformation formula based on addition. So we have sin c plus sin d is 2 sine into c plus d by 2 into cos c minus d by 2. Remember, this is the first formula. Sine on both the sides, you'll use first formula, that is sine and cos. Instead of c, we have 4a. Instead of d, we have 4b. So 4a plus 4b by 2 into cos c minus d by 2.
C is 4a.
D is 4b by 2, right? Now we have the sine 4c here. We're just copying the sine 4c here. Now we'll cancel 4 and 2. So we'll get 2a plus 2b, 2a minus 2b. Now what is sine 2a plus 2b? We know that sine a plus b is equal to sine c. This is if a plus b plus c is equal to 180 degree, right? Now how do we know what is sine 2a plus 2b? How do we know this? Here's the way. We need 2a plus 2b, correct? So we'll take a plus b plus c as 180 degree. We'll multiply both the sides by 2. We'll get 2a plus 2b is equal to 360 minus 2c. We did the same thing in the tan problem, right? We did the same thing. We applied tan on both the sides. Now we are going to apply sine on both the sides because we need to find out sine 2a plus 2b, right? And we can write this as sine 2 into 180 minus c. This is like sine 2a. What is sine 2a? Sine 2a is 2 sine a into cos a. This is sine 2a. Now instead of a, we have 180 minus c. So instead of a, we'll put 180 minus c here, right? And we know sine 180 minus c. Sine 180 minus c is, what is sine 180 minus c? It is nothing but sine c. So we put sine c. And what is cos 180 minus c? Remember, cos will have a negative sign. So it's minus cos c. So we got minus 2 sine c cos c. What is this? What is 2 sine c cos c? It is sine 2c with a negative sign, right? Now we got sine 2a plus 2b as minus sine 2c. Now let's go back to the problem and substitute. Here we'll have to substitute minus sine 2c. Then instead of 4c, instead of sine 4c, we know sine 2a. Sine 2a is 2 into sine a into cos a. Now for sine 4a, what we'll do? We will double it up. Sine 4a would be 2 sine 2a into cos 2a, right? When it was 2a, it was a here. When it is 4a, it will be half of this, which is half of 4a is 2a, right? When it was 2a, half of 2a is a. When it is 4a, half of 4a is 2a. If it is sine 6a, we'll have to do the same thing. If it is sine 6a, we'll have to write it as 2 sine 3a into cos 3a. That is, we'll have to take half of 6a. We'll have to take it as 6a by 2, half of 6a. Now, we have done this. So if you notice, sine 2c and sine 2c here, it's common. Let's take the common factor. We'll take sine 2c as common factor. We'll be left with this. Now, we'll bring this in the form of a plus b, a minus b, right? We'll bring this. Only then you can apply transformation formula. Here we have a minus b. We can write 2c as 2a plus 2b, right? Because cos a plus b is equal to minus cos c, correct? So if cos c is equal to cos a plus b, then what will happen to cos 2c? What will be cos 2c? It will be cos 2 into a plus b, right? Which is nothing but cos 2a plus 2b is cos 2c. We'll have to remember the negative sign. Here there's negative sign, right? There is negative sign here. We have plus cos 2c here. So instead of cos 2c, we can write it as, we can write cos 2c is equal to shift minus this side. So it will be minus cos 2a plus 2b. Minus cos 2a plus 2b. Now we can use the transformation formula, right? This is of the form cos a plus b minus cos a minus b. So we'll have to use the first set, right? First set. This one. We'll have to use the fourth formula. We have negative sign and cos a minus b. So we have a minus b and a plus b. So we'll have to use this formula. Let's shift to this side, right? So it will be 2 sine a into sine b. So this is going to be 2 sine 2a into 2b. Because instead of a, we have 2a. Instead of b, we have 2b. 2 sine 2a into 2b, right? And we have minus 2 sine 2c. Now we'll multiply. We'll get minus 4 Sine 2a into sine 2b into sine 2c. Let's take another problem where we have to prove that cos square a plus cos square b minus cos square c is equal to 1 minus 2 sine a into sine b into sine c. Now, notice that there is square here, right? And we have to get it in the form of sine a, sine b, sine c. There cannot be any power in the RHS, right? RHS doesn't have any power, which means first clue is we'll have to remove this square. We'll have to remove the powers. So, one formula we can think of is cos 2a formula. Cos 2a is 2 cos square a minus 1. There are 3 formulas for cos 2a. We'll use cos based formula, which is 2 cos square a minus 1. From this formula, we'll try to find out the value of cos square a. Cos square a is nothing but, you shift everything here, you'll get cos square a is cos 2a plus 1 by 2. Now we'll substitute here. We'll substitute cos 2a plus 1 by 2 here. For cos square b also we'll substitute. For cos square c also we'll substitute. Same formula. Now we have the same denominator, so we can take 1 by 2 as common. 1 by 2 as common. And we'll add up all the numerators. So it's going to become 1 plus 1 plus 2, 2 minus 1. It's going to become 1. 1 plus cos 2a plus cos 2b minus cos 2c. Now we'll use the transformation formula, right? We have cos 2a plus 2b. Which formula we can use? This is addition. So we'll have to use second set. Second set. What is the second set formula? So we'll have to use the second set of formulas, right? Where we have cos c plus cos d. We'll have to represent it as cos c plus d by 2 into cos c minus d by 2. So this is in the form of cos c plus cos d. This is in the form of cos c plus cos d is equal to cos c plus d by 2 into cos c minus d by 2. This is the third formula. And we'll have to remember there is 2 here, right? So instead of c we have 2a, instead of d we have 2b, and by 2, c plus d by 2, 2a plus 2b by 2. We'll substitute here and then we'll just carry forward cos 2c. Now 2 and 2 will get cancelled here. So we'll be left with 2 cos a plus b into cos a minus b. Now what do? We'll convert cos 2c as, we'll write it as 2 cos square c minus 1, right? What is cos 2c? Cos 2c is 2 cos square c minus 1, right? We'll substitute here 2 cos square c minus 1. Since there is a minus, so it will be minus 2 cos square c, minus and minus 1 will become plus 1, right? Now we'll take, if you notice, cos c is common here, right? So we'll take cos c as common, we'll get this expression. Now, if we have to use transformation formula, it should be of the form a minus b and a plus b, correct? Only then we can use transformation formula. So what we will do, instead of c we can write a plus b. We know that, right? Trigonometric identity. Cos a plus b is equal to minus cos c, the third angle, right? Cos of 2 angles is minus cos of third angle. Remember the negative sign always for cos. So instead of plus cos c, we'll write minus cos a plus b, right? Cos c would become minus of cos a plus b. Now we can use transformation formula because we have in the form of a minus b and a plus b. So we'll have to use which formula? We'll have to use the first set of formula. This is the first set. This is the fourth formula. We have cos a minus b minus cos a plus b, which is nothing but 2 into sin a sin b. So we'll write this as 2 into sin a sin b. And on simplifying this, we'll get 1 minus 2 sin a into sin b into cos c, which is equal to RHS. Now let's take this particular example. Sin 2a plus sin 2b plus sin 2c by sin 2a plus sin 2b minus sin 2c is tan a into tan b. Now what we will do, we'll take these two terms, apply transformation formula, take these two terms, apply transformation formula. So it is second set, sin c plus d, right? It is of the form sin c plus sin d. First formula in the second set, right? First formula in the second set, which states that sin c plus sin d is 2 into sin c plus d by 2 into cos c minus d by 2. This is the formula. So we'll substitute this formula here, both in the numerator and denominator. And instead of sin 2c, we'll write as 2 sin c cos c, because sin 2c is equal to 2 sin c cos c. Similarly, in the denominator also, we'll use sin 2c formula. So now 2 and 2 will get cancelled. We'll be left with a plus b, a minus b, a plus b, a minus b. Now what we can do is, we'll get it in the form of a plus b everywhere, right? Instead of sin c, we can write as sin a plus b. Instead of cos c, we can write as minus cos a plus b. The trigonometric formulas, right? Sin a plus b is equal to sine of third angle, sine C. And cos A plus B is cos of third angle, cos C with a negative sign. Right? Now you substitute all of this. You take common factor. You notice sine A plus B is common. Here also sine A plus B is common. Right? These common factors will get cancelled and you're left with this particular expression. Now again, you can apply transformation formula. Here you'll have to apply the fourth formula in the first set. The fourth formula is nothing but sin A into sin B is half of cos of A minus B minus cos A plus B. So we'll shift 2 this side, so it will become 2 sin A into sin B. 2 sin A into sin B is this particular expression. Similarly, we'll do in the denominator. Here we'll have to use third formula. Cos A plus B and cos A minus B. What is the sum of this? It's nothing but cos A into cos B. We'll shift 2 here, it will become 2 cos A cos B. Right? 2 and 2 will get cancelled. Sin A by cos A is tan A, sin B by cos B is tan B. So we have the RHS. With this, we have come to the end of this particular topic. I shall put some more videos on additional problems. Thanks for watching. Hope this video was useful.